So here we have a nephron. Nephrons are the functional units within the kidneys. Your kidneys have millions of these. Now, most of the, something like 85% of the nephrons are going to look like this, where we're going to have the bulk of the nephron and its convoluted tubules found way up here in the cortex of the kidney. Now, the nephron is really going to start right here with our afferent arteriole. Now, remember that afferent means towards. In this case, what we mean when we say that it's going towards something is that we're actually going towards this structure here, which is called the renal corpuscle. The renal corpuscle is composed of two things. It's composed of this knot of capillaries called the glomerulus, and it's going to be composed of the glomerular capsule. So it's basically going to be this capsule around it. And we have a little bit of space in between them that we might call the glomerular space. Now, what we're really doing here is the glomerular capsule, or the glomerulus itself, this knot of capillaries, is set up as basically overlapping fingers of cells that are overlapping and creating these little tiny spaces in between them. There's actually multiple tissue layers that are going to be acting as this filter here. But while this is happening, when we push blood through there at high pressure, through this afferent arteriole, it's going to kind of get pressurized by the fact that the efferent arteriole is smaller. So we have more stuff coming in than there is coming out, which means that's going to put some pressure against the structures on the inside of the glomerulus. So it's going to put some pressure against this filter. Okay. Imagine pouring water into a coffee filter. The faster you pour the water in, the more the water is going to, the faster the water is actually going to come out through the filter, until eventually you pour it so fast that the filter breaks. Okay. Now, what we're looking at here then is we're going to have this blood coming in, pressing against this filter. And this filter is so small that it's going to stop everything from cells to larger proteins and even through most small proteins and hold that inside the blood. But it's also going to allow fluid and electrolytes, so things that are dissolved in that water that are smaller than small proteins. And those things are going to leave the blood and enter that glomerular space, where it will then eventually enter the next portion of the nephron. The blood cells, some of the water and large proteins and things like that, those will leave the glomerulus through the efferent arteriole. Now, this isn't showing you where that blood will then go. You'll notice that it's still red. It is still an arteriole, which means it hasn't gone through a different capillary bed yet. It actually hasn't gone through the capillary bed where we do gas and nutrient exchange. So we're actually going to use that later on once we get it to line up with different portions of the nephron tubule. Now, as we leave this glomerular space, or this capsular space, we enter this first set of twisted tubes. This first set of twisted tubes is called the proximal convoluted tubule. Proximal, well, what is it proximal to? That means it is proximal to the renal corpuscle, or proximal to the glomerulus. So this fluid is going to enter here into this thick portion of this proximal convoluted tubule. And you'll notice it's kind of twisty, twisty, twisty. That's why it's called convoluted. And then it's going to go down and it's going to run into this little hairpin right here. So when it starts this like downward curve, so it starts pointing down, and then we have this tight hairpin turn and then loops back up, we're going to call this the nephron loop, or the loop of Henle. Okay. This nephron loop is going to contain a descending limb, so the portion that's going down, and an ascending limb, which is the portion going up. Now, the way you're going to tell those apart is, once again, which one is closest to the glomerulus. Notice that this one, if we follow where the fluid came from, if the glomerulus is here, that means the fluid's going this way. So the fluid will enter the descending limb first before it ascends. Okay. Then it will go up through a distal convoluted tubule. So once again, we have a distal portion of this tubule that's twisted around. So we have the distal convoluted tubule, and that will then drain into these collecting tubules. And then finally, those all collect together. So all of the collecting tubules of various nephrons will then drain into a collecting duct. At this point, we now have urine. Before this, we might call it filtrate or something like that. We are still messing with the levels of substances in there, basically until we get to our collecting tubules, and then it's basically just going to be urine. Now, like I said, this is going to be at this kind of border between the cortex and the medulla, but the vast bulk of this one is going to be found in the cortex. So this is a particular type of nephron. Now, let's go ahead and look a little bit more at the structure of the nephron itself. So let's look at some of the tissue types that are going to be here. Well, this is a capillary. So if it's a capillary, we know that it's going to be composed of simple squamous epithelium. Now, this simple squamous epithelium gives us a really, really thin line so that we can easily move substances across it very, very quickly. Remember, we are relying on diffusion and pressure and things like that to move stuff here. Distances matter. So having something very thin makes this a little bit easier. Then we entered the glomerulus. Now we have some special cells in the glomerulus called podocytes. Podo means feet. So they're going to have these little feet. They're going to interlock with the feet of other podocytes, and we're going to form this little border here. But like I said, we have some other tissues underneath those, which are once again filtering out other substances. So we have the innermost layer of the endothelium, which is going to filter out the cells. And then we're going to have another layer above that. That's going to filter out larger proteins and keep larger proteins inside and make it sure it stays in the blood. And then finally, we have the podocytes on top of that, making sure that smaller proteins still can't leave through those little slits between their interlocking fingers that we're going to call filtration slits. Okay. Now, the glomerular capsule itself is also composed of simple squamous epithelium. But once we get into the proximal convoluted tubule, we are going to see lots and lots and lots of simple cuboidal epithelium. Now, whenever you look into a kidney, so whenever you are looking at kind of a cross section of a kidney, you're going to see lots and lots of proximal and distal convoluted tubules. And these are all going to be composed of simple cuboidal epithelia. If you look at one of these slides, you're just going to see thousands upon thousands of these little circles, where those circles are basically cross sections of convoluted tubules and collecting ducts. Now, the way that we're going to tell the difference between a proximal convoluted tubule and a distal convoluted tubule is that the proximal convoluted tubule is going to have lots and lots of larger cells, but also we're going to see a bunch of surface area on the surface, the luminal surface of the, or apical surface rather, of the simple cuboidal epithelium in the proximal convoluted tubule. What this is doing, this is giving us lots of surface area so that we have more surface area for reabsorption of chemicals that we want to reabsorb. So things that we don't want to get rid of, things that got pushed out into the filtrate that we want to keep as much of it as we possibly can. This gives us more chances to reabsorb those. It gives us more places to put pumps and protein channels and things like that so that we can pull in as many of those things as we possibly can. Okay. Now, as we move down, we're going to enter the nephron loop. Now, the nephron loop, like I said, has a descending limb and an ascending limb, but each of those is going to have a thick segment and a thin segment. The thick segment is once again going to be composed of simple cuboidal epithelia. The thin segment will be composed of simple squamous epithelia. Now, the loops of Henle are almost always going to be found in the medullary region of the kidney. Now, as we go up back to the thick segment, you'll notice that we get back into simple cuboidal cells, but notice that the simple cuboidal cells get a little bit smaller than they were in the proximal convoluted tubule. So relative size here matters. So distal convoluted tubule, they are smaller cuboidal cells than they were in the proximal convoluted tubule. One of the other big differences between them is that we have way less microvilli on their surface. So we might have a few here and there, but you're not going to see this nice, really dense brush border of microvilli on the distal convoluted tubule as you do in the proximal convoluted tubule. Now, once we get into the collecting ducts, we will see a few cells here and there, which will have ciliated or microvilliated borders. However, they are fairly rare. These cells that are doing this are what we're going to call intercalated cells. These are going to be fairly important, but the bulk of the collecting duct is going to be composed of what we call principal cells. Now, like I said, most nephrons are going to be what we call cortical nephrons. That's because the vast majority of the nephron itself is going to be found in the peripheral cortex, so in the cortex of the kidney. The nephron loops tend to be short, and they're basically just going to kind of dip down into the medulla for a moment. And that's really it. So we're talking about the relative position of the renal corpuscle, so of the glomerulus and the glomerular capsule, and then the length and positioning of the nephron loop. Now, the other 15%, though, are going to be what we call juxtamedullary nephrons. What this means is that the renal corpuscles, instead of being found way up into the cortex, are instead going to be found right at that borderline between the cortex and the medulla. So that's why juxtamedullary, because that means kind of in between. And then the nephron loops are going to be very, very long, and they're going to expand way down into the medulla. Now, what these are doing, though, is these are actually here to help us establish salt concentration gradients. What this means is we can regulate the amount of salt that we have here by either taking up less in the convoluted tubules or taking up less in the loops of Henle, and thus leaving some in, or taking up more so that we can lower interstitial salt concentrations. So this is going to be a very important part of us regulating the actual concentration of urine, particularly through our antidiuretic hormone, because this is one of the ways that we're going, or one of the changes that we're going to be making. So here we have that juxtamedullary nephron. Notice that the glomerulus is close to the borderline here. And then the cortical nephron, the glomerulus, is a pretty long distance away from the actual junction between the cortex and the medulla. Now, they also are going to have slightly different, or not even slightly, but very different capillary beds associated with them. Cortical nephrons are going to have a capillary bed wrapped basically all around the proximal and distal convoluted tubules. What we would call a paratubular capillary. Okay, so peri meaning around, tubular, so around the tubes, capillary. Over here on the right, we have the juxtamedullary nephrons, where we have a special set of capillaries called the vasa recta. That's going to be very important down here, extending down through the nephron loop. And once again, this is going to be important for helping us regulate urine concentration, as it will be hormonally controlled through antidiuretic hormone.